So here up here, we've got, is that okay?
Yeah.
Is that better than this? That's better. Oh, yeah? No, this is,
No. What are you doing?
I'm trying to find, this is okay. Okay, Carly, I misunderstood you. I thought you said it's too dark back here.
No.
But you're like, no, I like it like this back here. Okay, good. So January 2010, which if you remember back to that date, it's kind of at the tail end of the recession that we had in like 08, 09, 10. That was kind of the tail end, quote unquote, of the recession. It was brought up, I went to the COCC board meeting last night. One of the board members mentioned that now that we're out of the, she didn't say recession, now that we're starting to see economic indicators rising again. I'm not sure what she was talking about. I think she was talking about construction and things like that. But this was kind of that scary time when COCC's enrollment went through the roof. Because as it seems, community college enrollment seems to be inversely proportional to economic indicators. So as the economy tanks, our enrollment swell. Remember that? You guys are probably, I don't know, if you guys probably missed that, didn't you? I'm guessing it's 2014, you've been here for a couple years? So you might have been in at the tail end of that explosion. We're still dealing with it financially. But anyway, this was right about that time. And we had, I pulled 702 for sale Benz single family homes, and I used the acronym there. 65 were in foreclosure. And then the question is, what's the foreclosure rate? Now, I think we answered this one in class together, if I remember correctly. Right. And one of the quick and easy answer was simply to divide the 65 by the 702 and go, boom, done. Which was like 9% or something like that. Why is that wrong? Just to put 9%, or whatever it was.
That was smack in the middle, wasn't it?
It was smack in the middle, and that's what's called, thank you Nick for that, that's called the best point estimate for a parameter. So if you had to pick just one number, not that you should do this, but if you had to pick just one number to represent the population proportion little p, you'd pick the sample proportion p hat. But you should never just stop with that. And how come? Carly, how come?
You have to have your margin of error.
Why do you have to have the margin of error?
Because that's for your confidence.
Yes! The confidence. You have to have 95% confidence in this case. If you just give p hat, how confident are you? 0% confident. If you just give p hat, that means you cannot be wrong at all. And since you never know what the value of little p is, you have 0% confidence. There's no wiggle room around your result. And now, what's the problem with that? Suppose I go out and get 702 more homes, maybe even some are the same, some are different, but a different random sample. What's the chance of getting exactly 65 in foreclosure again? Essentially 0. What's the chance of getting close to 65 in foreclosure? That becomes pretty good, yes? So that idea of getting, if we do it again, we're going to get pretty close to 65, that's what the margin of error allows for. It allows for any completely random, completely acceptable error in your sample. That's why you have to have it. And that's why I wanted you to put it on the number line as well. Why that's important. So let's make sure we got the steps down again. Let's swing this. I wonder if we can do this. We'll just go back and forth. Oh, there it is from like yesterday. I guess I haven't used the TI since yesterday. Beautiful. Beautiful. Or from Tuesday. 1 prop z int. Same thing. We already calculated this on Tuesday together. So there's there's p hat. That's the sample proportion, 9.3%. But the problem is, and always will be and exists, is that we're not looking for p hat. P hat's only a teeny part of the picture. We need the value of little p. That's what we're doing right now. We're estimating the population proportion by using a sample proportion. So in order to be 95% confident, you have to say, I'm 95% confident that it's at least 7.1% and at most 11.4%. Let's see if I can add that right to, no, it's going to be on the wall, isn't it? I'll draw a number line over here. Ask me questions on that are still residual from Tuesday.
So you want us to write that actually out?
Well, that's the interval is that guy. I like the drawing too, the drawing on the number line, because then we can compare it to other things if you actually have a visual of it. So that's why I had you do that. I started at 1 to 12. So here we go. All right, we'll just put 6 in the middle. 12 over here, 0 here.
So we don't need to write out I'm at least confident or anything like that?
Oh, all I'm asking for is the interval.
Okay.
We'll get to the more interpretations you do, the better too, Linda.
Okay.
but all you really need, all I'm asking for is the intro. I'm focusing on mechanics now. Interpretations come later once we have mechanics in the bag. So I'm going from 7.1%, so that's like here. We'll do this in red. It's like here, to about 11.4, so here's 10, so that's about here. So this would be January 2010. There we go. Now the reason you need the margin of error again, what is the margin of error on that interval? What is the margin of error on that interval? What is it mathematically? Can you figure it out?
Yes.
Of course you can. I get a vote for 1.9%? So, remember, here is your interval. It's centered at 9.3%. I didn't draw it very well, did I? This should be over here a little more. There we go. Okay. So 9.2 or 9.3, 9.25 is the center. The distance from there to there is a margin of error. And the distance from there to there is the same margin of error. Remember, that's what you're doing. You're stacking the margin of error onto p hat. So how far is 9.3 from 7.1? 2.2-ish, something like that, 2.2%. There's your margin of error. Your margin of error is about 2.2%. Fair enough?
Yes.
That's the legitimate margin of error you have to use based on 95% confidence and based on a p hat value that you got in the study being about 9%. We'll come back to the mechanics of calculating margin of error momentarily. Any questions? Before we move on to the next few, I want to look at the next few as well and see how they all stack up and compare, literally and figuratively stack up and compare. Cool? Good. Now we move on. Let's swing this back over, go to the next